Today we are discussing about dental waxes. Dental waxes can be divided into pattern wax and processing wax based on its application. Pattern wax can be again subdivided into inlay wax, casting wax and faceplate wax. Inlay wax is an important short note or short essay which is usually asked for the examination. Its ADA specification number is 4 and it is used to form a carved pattern which helps in duplicating the size and shape of the restoration, which can be replaced by a definitely restorative material such as acrylic, metal or ceramic. Classification of inlay wax. According to ADA specification number 1, inlay wax can be classified into type 1 and type 2. Type 1 is medium wax which is made by direct technique. It exhibits minimum flow at 37 degrees Celsius to minimize distortion on removal from mouth. Then type 2 inlay wax is otherwise known as soft wax which is manufactured using indirect technique which shows maximum flow at 37 degrees Celsius. It can also be classified as hard, medium and soft inlay wax. What is direct and indirect wax technique? Direct wax technique, it is a process whereby a wax pattern is prepared in the mouth directly on the prepared tooth. Indirect wax technique, it is a procedure in which wax pattern is prepared on a die. In this picture we can see the direct wax technique. The cavity is prepared and the wax pattern was fabricated directly inside the mouth, and this is the post-operative photograph. In case of indirect wax technique, first of all impression is taken, cast is poured, dye is taken, then the wax is added in layers, it is carved out and then it is reinserted into the patient's mouth. Then applications. Specialized dental wax which can be applied onto the prepared cavity or to the dies to form direct or indirect patterns respectively. These patterns are used in the fabrication of indirect metal restoration such as inlays, crowns, FPD, RPD, etc. by lost wax technique. What is the mode of supply of inlay wax? It is available in blue, green, ivory or deep purple colors. They are supplied as either pellets or sticks. They are available in preformed shapes for partial dentures and also in packed cans. Then medium or hard inlay wax. Here the modifiers are added in order to reduce the flow and thermal expansion at the temperature of oral cavity, and it is mainly used for direct technique. This wax pattern is easy to remove from the model without any deformation and it can easily be carved. What is the composition of inlay wax? The base or main composition is the paraffin wax and microcrystalline wax which accounts about 60%. The modifiers are carnauba wax and candelilla wax, sarrasin wax, bee wax, gum damma resin, colorants and pigments. What are the ideal requirements of inlay wax? The wax should be uniform and softened and it should be compounded with ingredients that blend with each other so that there are no granules on the surface and no hard spots within the surface. The color, it should contrast with the dye materials or the prepared tooth. Also, it should have sufficient opacity in thin layers to facilitate proper finishing of the margins. It should not flake or crumble or should not be pulled away by carving instrument. It should not leave any residue on burnout. It should be rigid and dimensionally stable till it is eliminated. Then manipulation of inlay wax. Inlay wax may be softened over a flame or in a water at 54 to 60 degrees Celsius to enable their flow. Usually heating in water bath is avoided as it can result in the inclusion of droplets of water which can splatter on flaming. It may smear the wax surface during polishing and it may distort the pattern during temperature changes. Direct technique. For direct patterns, the wax is heated over a spirit lamp and the softened wax is made into a cone and is inserted into cavity. Then pressure is applied with operator's finger or patient is asked to bite into it. The wax hardens at mouth temperature and it may be carved inside the oral cavity. Direct technique. The wax is made into a cone, inserted into cavity, pressure applied with fingers or either patient is asked to bite onto it. To fabricate the indirect patterns, the die should be lubricated, usually with a lubricant containing a wetting agent. Any excess must be avoided because it will prevent intimate adaptation to the die. These melted waxes may be added in layers with a spatula or a waxing instrument. The prepared cavity is usually overfilled and then the wax is carved with heated instrument. When the margins are being carved, care should be taken to avoid abrading any surface of the stone die. A silk or other fine cloth may be used for final polishing. So in indirect technique, we should mark the cavo surface margin, apply the separating medium, then the wax is added in layers. Then what are the properties of inlay wax? First one is flow. It's a change in shape or dimension in response to an applied force. At low temperature, usually the wax is hardly flow, but as the temperature approaches the melting range, the flow increases dramatically. For pattern wax, the flow is generally not desirable, but for processing wax, the flow is a highly desirable property. Flow usually depends on the temperature of wax, the force bringing about the deformation, and the time of force of application. So the maximum flow permitted for type 1 wax at 37 degrees Celsius is 1%, and their low flow at this temperature permits carving and removal of the pattern from the prepared cavity at oral temperature. Both type 1 and type 2 waxes at 45 degrees Celsius must have a minimal flow of 70% and a maximum flow of 90%. Thermal conductivity. The thermal conductivity of the waxes is low, so sufficient time must be allowed both to heat them uniformly and to cool them uniformly. Coefficient of thermal expansion. It have got high coefficient of thermal expansion, that is about 350 into 10 raised to minus 6 per degree Kelvin. Usually the expansion rate increases abruptly above approximately 35 degrees Celsius, and at this temperature at which a change in rate occurs is known as the glass transfusion temperature. Oxidation. Because the wax patterns are to be melted and vaporized, no excessive residue should remain in the mold because of incomplete wax burnout. The excess residue may result in the incomplete casting of inlay margins. Modulus of elasticity. It measures an object's resistance to being deformed elastically when a stress is applied onto it. It usually depends strongly on the temperature. The next one is ductility. The inlay wax should have moderate ductility. It allows the wax to be more plastic so that it will deform rather than fracture, and it allows the wax to be carved and varnished. And the last one is the distortion or warpage of wax pattern. A newly made wax pattern, it may tend to change its shape and size over the time. Like other thermoplastics, the wax tends to return partially to their original shape after manipulation, and it is known as elastic memory. To demonstrate this effect, a stick of inlay wax can be softened over a Bunsen burner, can be bent into a horseshoe shape and chilled in this position. If it is then floated in room temperature water for a number of hours, the horseshoe will open. Here we can see that a stick of inlay wax is bent into the shape of a horseshoe and it is floated on water at room temperature, and after 24 hours, the same stick of wax tends to relax and distortion occurs. A thermoplastic is a material which is usually a plastic polymer which becomes more soft when heated and becomes hard when cooled. So the thermoplastic materials can be cooled and heated several times without any change in their chemical or mechanical properties. The next one is residual stress. It is the stress that is remaining in a wax as a result of manipulation during heating, cooling, bending, carving or other manipulation. This manipulation of wax puts the molecules of the wax into positions that they do not like but cannot change because of their solid state. These stresses that are present in wax generally are released as the temperature of the wax increases and the wax molecules can move more freely. Then what are the causes of warpage? First one is physical deformation, which usually occurs during molding, carving or removal. Distortion of a wax pattern usually results from the occluded air in the wax pattern and the release of the stress which is trapped during the previous cooling, excessive storage time and extreme temperature changes during storage. And the distortion is increased generally as the temperature and the time of storage are increased. In general, the higher the temperature of the wax at the time of the pattern was adapted and shaped, the less will be the tendency for distortion in the prepared pattern. Prevention of warpage. The incorporation of residual stress can be minimized By softening a wax uniformly by heating at 50 degrees Celsius for at least 15 minutes before use, or by using warmed carving instruments and a warm dye, or by adding wax to the dye in small amounts. So these are all the properties of Inlay wax.